Hi, for today's Advanced Concepts Presentation 6, I'll be talking about aspirin and its pathways and mechanisms and how it relieves pain, inflammation, and has its other relieving effects. So to begin, we have to talk about which substances it interacts with and its effects. The substance is arachidonic acid. Arachidonic acid consists of 20 carbon atoms and 4 double bonds. The structure is here to the right of arachidonic acid. This fatty acid is derived from linoleate and it has several functions within the immune system, in allergies, inflammation, mood, and appetite. Arachidonic acid is a precursor for various substances that specifically carry out those functions. Those substances are prostaglandins, which I will focus on in this presentation, prostacyclins, thromboxanes, and leukotrienes. So here's a nice infographic about that. So arachidonic acid creates leukotrienes, prostaglandins, prostacyclins, and thromboxanes. There are also the enzymes that are involved in the synthesis of these substances. And for this presentation, I will be focusing on prostaglandins and how aspirin interacts to inhibit the synthesis of prostaglandins, therefore provide pain relief. So prostaglandins have several specific roles. One thing they do is stimulate inflammation. So if you have an injury and that area becomes inflamed, you can thank prostaglandins for that effect. They also regulate blood flow to different organs. They control ion transport across membranes. They modulate synaptic transmission as well as induce sleep. Those facts come from our textbook. So when it comes to aspirin, we want to talk about how it interacts with arachidonic acid to actually exert its analgesic effect. So aspirin blocks the active site on the cyclooxygenase enzyme, or the COX enzyme. And the COX enzyme is actually responsible for converting arachidonate into prostaglandin. So the fact that aspirin blocks the formation of prostaglandins means that there is down the line an effect on inflammation, blood flow to certain places, pain and clotting, as well as fevers. So here's a picture of the pathway and its intermediates. Unfortunately, my taskbar didn't want to disappear. But you can see up here, this is where we want to focus because the COX enzyme 1 and 2 are inhibited by aspirin. In the next few slides, we'll see specifically how it's inhibited, but that is the main takeaway from how aspirin interacts with arachidonic acid to inhibit prostaglandin formation. Because if you are to interrupt this and block that active site, you won't be able to make these intermediates to then make the prostaglandin that would create inflammation and increase blood flow to areas. So here's the mechanism I drew out, and we'll focus on this side of the mechanism. And what's important to note here is that aspirin, its specific mechanism is that it acetylates the serine residue in COX-1. So here would be the COX-1 enzyme, and the serine that is at the location of 530 is inactivated. This is the inactive residue, which then inhibits PGG2, that's prostaglandin G2, that's the specific prostaglandin we're talking about, and therefore prostaglandin synthesis is inhibited. So it won't make any prostaglandin. On the other side, you see that aspirin does also interact with the other byproducts of arachidonic acid, and leukotriene can still be formed. So here we have the prostaglandin G2, and that's inhibited by the aspirin. That's the actual enzyme or the actual substance, the structure of the substance that is inhibited. And therefore, that's how aspirin on a mechanistic level operates. Thank you.